Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today we will talk about topic 5 is water. Before we start, my name is Nurul Safir binti Jamlun and my partner is Bernadette Bangi, anak William Mandau. Alright. As you know, water is one of the most important thing in life. Water, food are some of the things that keep us healthy. Alright, what is water? Alright, water is called H2O. This is the scientific names. I guess that you will give water. Alright, water is a molecule. Water is a liquid, and there are a lot of different ways to describe it. H2O stand for hydrogen and oxygen. There actually two hydrogen and two hydrogen atom and one oxygen atom that from bonds that you get a molecule that's called of H2O. Let's start with the video first.
Did you know that humans can live for only a few days without water? Did you know that water is the most important factor to human life after air? But why is water so important? Water makes up about 55 to 60% of an adult's body weight. It keeps us hydrated, not only quenching our thirst, but keeps our eyes, nose, mouth, and other sensitive areas well hydrated. Water helps transport nutrients and oxygen throughout the body. It helps regulate our temperature. When we feel too hot, we sweat to lower our body temperature and feel cooler. Water is important for lubrication. For example, saliva consists of water, so we can swallow our foods properly. It protects our joints. Water also helps in digestion, dissolves many solutes into our blood, and helps our body remove wastes. Water protects and absorbs shocks by insulating the fetus, brain, and spinal cord. Hope you found this video helpful. Like and subscribe.
The next slide is water for life. Water or H2O in your body contains numerous minerals like electrolytes. Electrolytes are minerals in your body that have an electric charge. They are in your blood, urine, tissue, and other body fluids. Electrolytes are important because they have balance the amount of water in your body, balance your body acid-base pH level, move nutrient into your cell, move waste out of your cell, and make sure that your nerve, muscle, and the heart and the brain work the way they should. Second is H2O makes up between 50 to 75% of your weight. Third is a leaner male, 62% H2O, 70% protein, 15 fat, and 6% mineral and glycogen. A leaner body means that more H2O since water helps muscle tone. It acts a lubricant around your muscle and joint. Protein contain more H2O. Muscular 70%, obese only 40% of H2O. Four is we can survive much longer without food than without H2O. And next is large H2O, obese 40%, muscular, and 70% protein, and contain more water than fats. Okay. Alright, next slide is a typical daily H2O intake and outputs. First, we talk about intake daily H2O. First is a food, 700 to 1000 milliliter. Drink, 550 to 1500 milliliter. Metabolics is 200 to 300 milliliter. Next, output, kidney or urine, 500 to 1400 milliliter. Like a skin, 550 to 900 milliliter. Lungs is 350 milliliter and feces is 150 milliliter. Next slide is a function of H2O. There have 6 function of H2O. First is a heart capacity. H2O high heart capacity. It takes a lot of hearts to change the temperature of the body. Second is a cooling ability. The warm blood vessel vasodilation component of sweets. Third is a participation in metabolism. Nearly all chemical reaction of metabolism involve H2O. 4 is a control osmotic. They are present in the body and maintain a proper balance between electrolytes. 5 is a main constituent of fluids, a major transport mechanism like oxygen, nutrient, hormones, and carry was a product of metabolism. And the last one is body fluid. Next is H2O balance. H2O balance, our bodies maintain H2O balance by mechanism that control H2O intake and H2O excretion. A low H2O, a kidney converts H2O, a reserve H2O, decreasing urine volume, concentrating the urines. High H2O, a kidney form and excrete a large volume of a dilute urines. For regulation of blood excretion is a H2O deficit, and then he go to increase stimulates osmoreceptor, and then he go to pituitary gland, release antidiuretics hormones or ADH, and then he effect on kidney conserve H2O, excrete solutes in highly urines. H2O RDA based on body size and composition, activity level, temperature, and humidity. 2.4 liter or 10 cup of water each a day. RDA or 1.0 milliliter to 1.5 milliliter per kilocalorie expended. Athletes and very active people need much more than this, especially if they train in a warm, humid climate. Adequate intake established for water under normal environmental temperature and activity level. Adequate intake for adult age 19 and over, males 3.7 liter or 3.9 quarts, and then female 2.7 liter or 2.9 quarts. Next is a water related diagram. First, blood water concentration fall to pituitary gland and release more ADH. and then he go to more water reserved from a kidney tubules, a small volume of concentrate urine, and then he go to the blood water concentration arise, and pituitary gland release a less ADH to less water reacts from kidney tubules, a large volume of dilute urine, and then he go to the first step, blood water concentration falls. Alright, next slide is a substance that affect fluids balance. First affect fluids balance is alcohol, caffeine, diuretic medication, and high protein diet.
Good day everyone, my name is Bernadette Bangi, and now I'm going to continue our chapter 5, which is about hydration status and performance. In this slide, hydration and status and performance, we're going to talk about inaccessible water loss. The second one is fluid replacement for endurance event, and the third one is factors that influence the rate of absorption of sport drinks, and the fourth one is how dehydration and hypohydration affect physical performance. Next is the guideline that ACSM gave to fluid replacement during exercise or competition, and the last one, heat acclimatization. And we're going to the next slide, which is inaccessible of water loss. In this slide, inaccessible water loss is about continuous evaporation of water from the lung and skin. Typically, account for about 1/4 to 1/2 of daily fluid loss. There are three factors of inaccessible water loss, which is high altitude, low humidity, and high temperature. Although possible with prolonged exposure and or physical activity. As you can see from the graph, it is about the graph about people going out during hot temperature, which is when the temperature is very hot and people going out, and that graph is show that how much heat that we accept from the sun. If we under the sun for a very long time, of course make water in our body loss. Next is a strategy how to prevent excessive increase in body temperature during exercise in hot environment. There is three strategy, which is skin wetting, hyperhydration, and rehydration. Next slide is about recommendation of fluid replacement for during events. As you can see from this slide, before event, athlete must drink water in about 1.5 to 2.5 cups of water in 2 until 3 hours prior to exercise. Large athlete may consume a greater quantity. Fluid consume not just only water but carbs and electrolytes, which is they can drink 100 plus. That any sport drink that our coach provide suggested to the athlete. Sport drink containing 4 to 8% carbs are preferred. And during event, athlete must drink a small amount of water, which is about 1.5 cup of fluid every 15 to 20 minutes during event. During event, if the athlete have a heavy sweating, and in the hot environment, they are necessary to add fluid in their body. Fluid consumption may be enhanced when fluid is cooler, which is 5 to 15 degrees Celsius. Fluid consumption may be enhanced when fluid is flavored. What this means is sport drink, which is like 100 plus. 100 plus has a little bit of flavor, which is sweet flavor, and athlete can drink it. As you can see that sport drink during event is very important to the athlete, and that's why every time there is a sport event, teacher will always provide 100 plus to the athlete to keep the athlete have a fluid in their body. And after event, athlete must drink 2 to 4 cups of fluid during the first 30 minutes after event. This is to make sure our body have enough fluid in our body. Fluid consumption may be enhanced when fluid is cooler and flavor. This sentence mean the water that we drink after the sport event must be the cooler and must have flavor. We usually see that after the event, athlete always buy their drink, which is a cool drink and have a very sweet drink because when we are very tired, of course our body need more fluid, more water. We usually drink a sweet that we usually drink a sweet flavor. This is a video about why athlete must drink water before event, during event, and after event.
Did you know that water accounts for about 60 to 70% of an athlete's body weight? Understanding how beverage composition affects hydration and energy replacement can help athletes develop smart fluid replacement strategies to maintain peak performance. Your gastrointestinal and circulatory systems are a bit like a highway. As the primary ingredient in the blood, water enters the vast highway system and transports important nutrients to where they're needed. Fluid replacement can be broken down into 3 main phases: intake, delivery, and retention. A properly formulated sports beverage will help during all 3 phases. Fluid intake, like taking the on-ramp to the highway, is the critical first step in getting fluid into the body. An athlete's desire to hydrate depends in part on the flavor and sweetness of the beverage, as well as the sodium composition, which stimulates thirst and improves the drinking response. Getting those and other factors right helps ensure athletes consume the fluid they need. The second phase of fluid replacement is fluid delivery. Rehydration is important because the body uses sweat, composed largely of water and salt, to keep its core temperature from overheating. Like blocking a lane of traffic, studies show that significant dehydration, measured as more than a 2% loss in body weight, impairs the body's ability to regulate its temperature and can hurt endurance and team sport performance. The sweating rate of athletes varies widely, typically ranging from between 1/2 to 2 liters of fluid per hour. Factors like genetics and exercise intensity and environmental conditions like temperature, wind, and humidity can have a big impact on individual sweating rates. Comparing an athlete's weight before and after exercise is the simplest way to estimate fluid loss. 1 pound is equivalent to about 16 ounces of water. To understand the total sweating rate, the amount of fluid the athlete drinks during exercise is added back in. So if an athlete loses a pound during 1 hour of training, or the equivalent of 16 ounces of fluid, but also drinks 16 ounces of water during the same time, the athlete's sweating rate is 32 ounces an hour. Measuring fluid loss under different conditions, such as varying weather temperature or intensity levels, gives athletes a clearer picture of how much fluid they need to stay hydrated, but avoid overdrinking. For training or competition lasting an hour or more, consuming the right amount and types of carbohydrates are shown to enhance endurance, high-intensity capabilities, and potentially skill-based performance. Experts recommend consuming 30 to 60 grams of carbohydrates per hour to fuel the muscles and brain during exercise. Maltodextrin and the sugars glucose and sucrose are recommended because they quickly digest and absorb into the bloodstream. A beverage formulated with up to a 6 to 7% solution of these carbohydrates is shown to exit the stomach and absorb into the bloodstream as quickly as water. For endurance athletes exercising over 2 to 3 hours who need to maximize carbohydrate absorption, adding to the mix a small amount of fructose, a carbohydrate that uses a different transporter than glucose or maltodextrin, has been shown to increase overall carbohydrate and fluid absorption. In general, more carbohydrate is preferable to less, but beyond a certain amount, the returns diminish and can even become negative because of slower absorption and potential for increased gastrointestinal distress. The final phase of fluid replacement is retention, which involves keeping fluid in the body to allow for rehydration. Salt intake is important in this phase because it's the primary electrolyte in the blood. It helps maintain blood sodium levels and tells the kidneys to retain rather than excrete the fluid ingested. After exercise is also a good time to consume additional carbohydrates and protein to help replace energy stores and rebuild muscles. By adopting a smart fluid replacement strategy that includes adequate fluids, sodium, and the right types and amount of carbohydrates, athletes can minimize fatigue and maintain peak performance.
The next one is about a factor that influence the rate of absorption of sport drinks. There are four factors, which is temperature, osmolality, and energy content, exercise intensity, and the last one is exercise movement. The first factor, which is temperature, cooler solution, 5 to 15 degrees Celsius may empty the stomach more quickly than warmer or hot solution. Cooler drinks are enjoyable and promote greater consumption, which is this mean in the hot temperature we usually drink cool water than warm water, because cooler water is very easy to make our thirst gone, and that's why during a hot temperature we usually want to drink cool water, because the cool water is make our thirst gone very easily. The second factor is the osmolality and the energy content. High fructose corn syrup has lower osmolality than sucrose or glucose. Concentration of more than 8% carbohydrate in the stomach can slow down gastric emptying. Osmolality means the concentration of solution expressed as the concentration of a solution expressed as a total number of solute particles per kilogram. The third factor is about exercise intensity. Athletes performing at higher intensity of relatively short time, for example 10-kilometer run, might benefit more from consuming sport drinks. Mild to moderate exercise intensity do not hinder gastric emptying even when the about last several hours. For example, athletes that run 10-kilometer run, usually from the 10-kilometer run event, there is always a station that provide a sport drink every time the runner run past through the station. They can always drink the water that the organizer provide for them, and usually the organizer always provide the sport drink which is 100 plus. They always use 100 plus. And the last one is about exercise movement. Sport involving greater torso movement running or horizontal position swimming. Horizontal position, which is swimming, may be prone to esophageal reflux. The movement of stomach content into the esophagus during exercise. From this factor, exercise movement, the more we move, the more we want the water, right? So this proof that the rate of absorption of sport drinks is more higher if we have a exercise that make our body move very often, like exercise like running, swimming, that kind of sport can make the rate of absorption of sport drinks more higher. The next one is how do I know if I adequately hydrated? The first one is thirst. Of course, if we thirst, that means we need water to hydrate. And the second one is urine color. Deep yellow may indicate hypohydration. If our urine color is darker, that means we have a dehydration. And if our urine is yellow color, that means you have a hypohydration, which is a very good. And the third one is body weight changes. Is try to weight yourself before and after you drink water. Before you drink water, of course, you are your weight is very light, normal weight. And if you drink a lot of water after you weight yourself, before you drink, then you drink a lot of water after that, and of course your body weight will change because the amount of water in our body can influence our body weight. And the last one is rapid body weight changes are due to body water loss or gain. This is what it means by body weight changes just now. The next one is how dehydration and hypohydration affect physical performance. If you have a dehydration before you start a performance, of course you will have a low of energy and make you want to faint. Of course, dehydration can affect your physical performance. For example, if we do a running, you have a dehydration, of course you will faint during the performance. And if you have a hypohydration and during your running, you will have no problem with your running at all, and you can finish your running until the finish line. Increase in the intracellular and extracellular fluid volume, particularly blood volume, which is it can make the stroke volume decrease, cardiac output is decreased, heat storage increases, which is sweating rate decrease, skin blood flow responses also decrease. How can I determine my sweat rate? How to determine our sweat rate is to know our body weight. As you can see from this slide, body weight may be simple and effective measure of hydration status. How to know you have a hypo or dehydration? You can wet yourself nude in the morning after the urinating. After that, obtain two or three consecutive morning wet to establish a baseline. And the third one is women may need more measurement due to the fluctuation of body weight associated with a menstrual cycle. The last one is body weight should be stable and not vary by more than 1%. This table is the example how to know your sweat rate. The next slide is about ACSM fluid replacement guidelines relative to fluid replacement during exercise or competition. The goal of ACSM is to prevent excessive dehydration, body weight loss from water deficit. The amount and rate of fluid replacement depends on the individual respiratory rate, duration of training, and chance of rehydration. Athletes should monitor weight changes during training competition seasons to estimate fluid loss while performing specific exercise tasks. Possible starting point for marathon runner is to drink at libitum 0.4 to 0.8 liters of fluid per hour. Smaller runner at 0.4 liters and larger runners is at 0.8 liters. This is the guideline that SCSM provide to know to fluid replacement during exercise or competition. And this table is about heat injury. There is 5 types of heat injury, which is heat syncope, heat cramps, heat exhaustion, heat stroke, and hyponatremia. As you can see from this table, you can learn how to do a treatment for this heat injury. Heat acclimatization is a biological adaptation that reduce physiological strain, improve comfort, improve exercise capacities, and reduce the risk of serious heat illness during exposure to heat stress. Usually, the heat acclimatization is happen to the athlete that exposed to the heat. For example, like cyclists, marathon runner, that any kind of sport that exposed to the heat. Heat acclimatization is specific to the climatic heat, stress, and physical exercise intensity. The athletes are exposed to, which should stimulate the expected competitive environment. As you can see from this slide, this is what happened during the heat acclimatization. All that list in this slide was increased during the heat acclimatization. As you can see from this diagram, it is about the heat acclimatization. When the heat acclimatization happen, this is the part of our body that will affect, which is heart, core, blood, performance, perception, sweat, muscle, and skin. For example, skin, low resting skin temperature, low exercising skin temperature, high skin blood flow sensitivity, high maximum skin blood flow. And this is the graph about the heat acclimatization that happened. As you can see that during day 1, our sweating rate is very low compared to the day 14. And of course, from this graph we can see that there is a very different in terms of sweating, blood volume, core temperature, heart rate, and sodium loss. And that's all from our group for chapter 5. Thank you for watching.